Hi guys, so we're officially at 1C. It's our last learning target for Unit 1, and we are talking about interval notation, and next time we'll talk about domain and range. Okay, so again, your learning target is up here. By the end of 1C, you should be able to do these things. Okay, so first of all, you should be able to recognize and find the domain and range of functions in what we call interval notation. We already talked about interval notation a bit in 1A when we were doing those key features, when we were talking about increasing and decreasing and constants. But this time we're explicitly going to teach interval notation. Okay, and then next time we'll talk about understanding and identifying domain and range and relating the domain and range to a graph and what it describes. Okay, so let's look again at our toolbox. These are our definitions and our important things. Okay, so here's our toolbox. So first of all, we have something called a set. And all a set is it's a collection of objects. In math, it's often a collection of numbers, okay, whose contents can be clearly determined. Okay, each of these things in the sets are known as elements, right? So if we talk about a set as a group of numbers, each of those specific numbers are known as elements, okay? And when we talk about sets of real numbers, they can be presented using one of the following forms. Okay, the first is set builder notation. Okay, in this notation, elements are described, but they're not listed. So example, here we have n equals x, where all the x values are greater than 3. Right, so oftentimes we see set builder notation with our inequality symbols, things like greater than or less than. Okay. And what this means is the set contains all numbers that are greater than 3, right? So x greater than 3, okay? Note that the small vertical line, this vertical line here, it stands for the phrase such that, right? So all real numbers such that they are greater than 3, something like that, okay? We can also determine, represent them using a graph, specifically a number line, okay, by placing a dot at the correct location for each number, okay. We've seen number lines before, right? The values of the numbers increase from left to right. As we move right, they get bigger, okay. If we are considering an entire span or interval of numbers, rather than just a set of individual values, we use something called shading to indicate all the numbers in between, all the numbers in that interval, okay? And then the new thing for us is actually interval notation. Like I said, we saw this before. And interval notation is when we use parentheses or brackets to define sets on the number line, okay? And what we do is we show the number at the end of the interval separated with a comma, okay? We always go from least to greatest. So we list the smaller number first and then the bigger number, okay? The arrows, when we're graphing, indicate that it goes on forever. And when we translate that into interval notation, we use negative infinity for the left and positive infinity for the right, okay? And please keep in mind that in interval notation, parentheses are always used to surround negative infinity and an infinity. Okay? If we have multiple intervals, we use the union symbol, U, to link together any of the gaps. Okay? So interval notation, we saw it briefly last time in 1A, and now we're going to look at it more closely. Okay? So in interval notation, these are some of our symbols. We use parentheses if those numbers that we list are not part of it. If we're excluding those numbers, we use parentheses. If we're including it, we use brackets. All right? In set builder notation, that is indicated as less than or greater than, where they don't have that line in between. Line under. Right? Versus if we do have that line under, we're including it, right? It has the possibility of being equal to. When we're graphing, if we don't want to include that number, we use an open circle, which looks like this. If we do want to include that number, we use a closed circle. Okay, and this is later on when we're graphing lines, specifically graphing inequalities. We use a broken line or a dotted line if we don't want to include it, or we want to exclude it, and we use a solid line to include it. Okay. And the last two terms we'll look at tomorrow. Okay, so let's start by looking at interval notation. Okay, so here we're understanding interval notation. Okay, so here we have a graph, okay, and you can see that all of the numbers in the graph are included, right? This arrow shows that it's going to go to the right forever, it's going to go to the left forever, and it's shaded to show that everything in between is included. If we were to describe it, we would say x is all real numbers, okay? In set builder inequality notation, we use the curly braces. Okay, we write x. And then some people use the colon. Some people use that line like you saw on the first page. And if I want to talk about how all real numbers are included, I would write the symbol for all real numbers. Okay, and that's like this special looking R here. And then I would close it. If I were to write it in interval notation, I would write it like this. Negative infinity, comma, infinity, right? So it covers all my numbers from negative infinity to infinity, which is all possible numbers, okay? You always start with a smaller one. You end with the bigger one. If it is an infinity, you use parentheses to surround it. Okay? The next one here, we have an open circle on A, which means A is not included as part of the set, okay? Going to the right forever, okay? Indicated by the arrow, okay? The description is x greater than A. And if we were to write this in set builder notation, okay? I start with this always, my brace with the x and the colon, or some people put that straight line, okay? And then I just write x greater than A, okay, as the inequality, okay? You guys have seen stuff like this before it. Okay? If I were to write it in interval notation, right, I would indicate that it starts with A, and then since it goes to the right forever, indicated by that arrow, it goes towards positive infinity. Okay? Because A is not included, right, it's open circle, it's not equal to, then I'm going to use a parentheses. Okay? And then on the other side, infinity is always with a parentheses. Okay? And so that is it in interval notation. Okay? When we use it in math, of course, though, we would put an actual number in for A. Okay? So the next one here is x is less than or equal to B. Right? So here we see a closed circle for B, meaning I include B, and it's going to the left forever, indicated by this arrow. Okay. If I were to write it in set builder inequality notation, right, always starts with that curly brace and x and the colon, right, I would write x is less than, that's the symbol for less than, or equal to, because it includes B, it's a closed circle, I have that equal to, that line at the bottom, to B. In interval notation, okay, I start with my smaller number. Okay, since this is going to the left forever, indicated by the shading in the arrow, it's going towards negative infinity. Okay? Then the biggest number that it stops at here would be B. So I would put B. Okay. Because B is included, right, it's a closed circle, it has the equal to, I'm going to use a bracket. Okay, and then on the other side, negative infinity, the infinities always come with parentheses. Okay. Then the next one here, okay, we have an open circle at A and open circle at B, meaning that A and B are not included. Okay, but what is included is everything in between. Okay. So the description is x is strictly between A and B. If I were to write it as an inequality, I would write it as A is less than X is less than B. Okay? And that covers everything between A and B. In interval notation, start with my smaller number, so that's here at A. End with my bigger number, this is B, so A comma B. A is not included, right? It's an open circle. There is no line under it, so that's a parentheses. B, open circle, not included, right? Not equal to, so that would be a parentheses as well. Okay. The next one here is X is between A and B to include A, right? So what I would write is similar to the last one, A less than X less than B, but because A is a closed circle, I'm including A, so I have to put this line, right, because it can be equal to A. As an interval notation, start with my smaller one, so that's on the left, and that's A. End with my bigger one, that's B on the right. Okay. A gets a bracket, okay, because it is a closed circle. It's included. It's equal to, so that's a bracket. B is an open circle. It's not included, so that's a parentheses. Okay. Then here we have X is less than A or greater than or equal to B. So I'm going to start with X is less than A. Okay, so always starting with this. Okay, so X is less than A. X is less than A. Okay. Or it's greater than or equal to B. So X is greater than or equal to, so that's the line, to B. Okay. Then I'm going to write this in interval notation. So I'm going to start with this side first. Okay. Since it's going to the left forever, that's going to be negative infinity, comma, it ends here at A. A. Because it's an open circle, it's not included, it'll be a parentheses. Okay. Parentheses always goes with the infinities. Okay. Then I'm going to work on B. Okay. So it starts at B, and then it goes to the right forever, indicated by the shading and the arrow, so that goes towards positive infinity. Okay. B has a closed circle here, so it is included, so that's a bracket. And then with the infinity signs are always a parentheses. Okay. Then here I have X is equal to A or greater than B, shown by this graph. Okay. So X is equal to A, so X equal A, or greater than B. So or X is greater than B. All right. Okay, how would I write it? Okay. For A, that's a little harder to include. Okay. But then for B, same thing. Starts at B and then goes towards infinity forever. So B comma infinity. Open circle, so B is not included, so that means it's a parentheses. And it's always a parentheses for infinity. Okay. So if you see on these two, right, I have two intervals or two sets. Okay, so to show that they're both included, I'm going to use a union. Okay. So whenever you have more than one of these intervals, you're going to connect them with a U for union. Okay. Last one here, X is all real numbers excluding A. So I have this side and this side. So again, I was going to start here. So I'm going to start with X's that are less than A. So I'm going to write X less than A. Okay. Or X's that are greater than A. So or X greater than A. In interval notation, right, so this is going towards negative infinity and it stops at A. Okay. A is not included, so that's why it's a parentheses, right? Parentheses always with the infinities as well. Okay. And it starts at A and then goes to the right towards positive infinity Okay, again, a is not included, so that's why it's a parentheses, and then parentheses always goes with infinity. Since I have more than one interval, connecting it with a u. Okay? So that's it on interval notation. Hope you guys have a great rest of the day. Bye, guys.